Gregor is a particular solar telescope because it's one of the largest telescopes that we have. And the reason for that is mainly to be able to look at small structures on the solar surface. The bigger a telescope is, the larger aperture a telescope has, and the smaller is the detail that I can resolve on the solar surface. And this is why we try to make it as big as we could, given the circumstances here that we have with our facilities on the mountain. Gregor is one of the three largest solar telescopes of the world, and it's the largest in Europe. So it's a unique opportunity for European solar research. The key questions that we intend to address with Gregor are physical processes which occur in the solar photosphere and chromosphere, which is essentially the visible solar surface. Here we see the finest structures. Here we see energy coming from the inside of the sun emerging and being released into outer space and eventually also reaching the Earth. Here we see all the processes which will eventually influence the near-Earth space environment and which are therefore important to understand. And so Gregor looks at the visible spectral regime and the near-infrared spectral regime with high-resolution spectroscopy, with high spatial resolution, and with high time resolution, so we can study processes which occur within matters of minutes or even seconds on the solar surface at scales of smaller than 100 kilometers. Gregor will initially have three instruments which will be used for scientific observations. Two of these instruments are spectrometers, which are complementary both in the way how they look at the sun as well as the wavelength ranges that they cover. There is the Gregor filtergraph, which has been built by Göttingen and Potsdam, and which is used to look at very narrow band images of the solar surface, and the wavelength of which can be scanned, can be changed during the observation, so we can look at a small spectral regime. There is also the infrared spectrograph, which was a major contribution from the IEC, and it covers the spectral region between 1 and 2 micrometers. And here we have a narrow slit which covers the solar surface, and the light which enters the slit is then being spectrally dispersed, so we see several absorption lines in the solar atmosphere all at once. And in order to cover a larger field on the solar surface, we need to move the image of the solar image across that slit, which will take a while. The third instrument has been supplied by our institute. It's a very small instrument called the broadband imager, which essentially just takes pictures of the solar surface for doing morphological research of solar small-scale structures throughout the entire visible spectral range. But it also has, in addition, a possibility to look at the optical quality of the telescope. All of these instruments are being fed by an adaptive optics system, which compensates the atmospheric fluctuations of the image quality in real time and delivers a much better and sharper and calmer and stabilized solar image to all of these instruments. And also this system has been built by our institute, and we are going to augment this system with several deformable mirrors. So in the end we will have what it's called a multi-conjugate adaptive optics system that compensates a larger field of view of approximately 1 minute of arc. So we can see at once a fairly large region of the solar surface with a good optical quality. one of the next instruments that we are going to install here will be actually a stellar spectrograph. And this is going to be done in the next few years. And this instrument will allow us to also use Gregor during the nighttime. And although Gregor has been designed solely for looking at the solar surface, which requires special precautions, because of course that's a pretty hazardous thing for a telescope to do. There's nothing that prevents Gregor from also looking at stars. It's not a good general purpose astronomical telescope, but for looking at stars there are way too few telescopes in the world, because there are so many of these stars and very many of them need to be looked at for long periods of time. Why is looking at the sun important, even though we have economical crises? That's a question with a lot of facets. I think that doing research and eventually transferring research results to applications and to industry is the best way to move forward with economy. Why should we in particular look at the sun and don't spend our time in doing something which could be conceived as being more important? Well, the sun is perhaps the astronomical object which influences life on Earth, and in particular our civilization, the most. The further our civilization develops, in particular the more it uses space, the near-Earth environment, the more we need to pay attention of how the sun behaves, because it has a huge influence on systems which are being operated in the near-Earth environment. The sun is actually a very complex physical system, and our aim is to understand this the good that we can in order to be able to predict its influence on our civilization better than we can do right now. This is why we are doing what we are doing here. We are now operating our facilities here since, the better part of a quarter of a century, which is a pretty long time. And I think that this past 25 years has been a very good time for astrophysics research and for solar research in particular. I think the Canary Islands have shown to be an outstanding site for doing research, and the relation to the Spanish science environment, and I would like to in particular to mention the ISC, has been excellent. We are grateful that we are here, that we can operate our facilities. We have hosts who help us so much, and who actually are so good hosts. And I think this is something that I really would like to say to all of you, because it's a privilege to be up here on the mountain and to be able to work.